Hello again. Welcome back to Leopard Street. Previous video, been working on the track work, and I mentioned in this video, move your chair out of the way, what I was going to do is work on the block detection and start powering some of the track up. I'm actually going to leave that because I'm fairly close to doing another order for some more track over here. What I actually want to do is get all of this track work down, soldered, cut. I'm not going to go through it all on film. I'll show little bits of it. Before I start taking things apart and trying to wire things up. Just because I only want to have to take it apart once. I mean, I'll have to do it all again when I do the other side of the station, but for now, just give me that. So, there's some other bits I want to be working before I flip the board over. And today, I'm going back to this one. I have another look at the turntable in this video. The goal is to get it powered up. So I'm going to go through a couple of the stages, a little bit of pre-work I've got to do, and we have a look at that. So, without further ado, on with the show, and let's go round and round. All right, so first up, this is, just move a few bits out of the way. This is the turntable. This is where it's going to go. There's going to be a track coming in here, so somewhere about yay. And I'll put a little stub on the other side with a buffer stop on it. And there's going to be a storage road that way. Was thinking of two. There's sort of space, but if I just put one, it can go to the end. It's all usable as storage. If I put two, I've got to start curving them. Makes life a bit easier. Just to have single road. As I mentioned previously, this is 8mm thick. The idea, let's get the deck, is the turntable deck fits in here like so. Lower it into its hole. It sits nicely on there. Bring the deck back in. Sits in the gap, spins round. So then all I've got to do, that needs a, there's going to be some weight holding that down. Then it's a case of just laying a piece of track over here. I mean, it'll sort of come up to that and then the rails go over. Little bit of foam, little bit of cork, little bit of foam, little bit of cork over there, job done. This very, very simple 3D printing. Now, there's another step I need to do because it's all very well having this in and assume for a minute I've got it motorized. I need the position. And this is the first thing I'm going to look at is the position sensor. Reason for that is because I'm going to have to modify the one end of the table. Spoiler alert, it's going to involve a magnet. So I'm going to have to involve a magnet at one end of the table. Obviously, once this is all in place, it's going to be a bit difficult. That's also why, if I pull this out, there's a notch here, because I'm going to put a sensor on the outside. It'll be around there somewhere. When this finally goes in, the table will power up in that position. It'll power up in that position. If you've used one of these Pico turntables, you will know there's sort of a dead angle. Basically, while the sensors go over there. So it's actually about there. So yeah, I'll have to rotate it. But I'm going to need to know, when I switch this on, the behavior I want is I'll turn it on. It'll go round to a position, probably about there. It'll back off a bit. It'll come in more slowly. Right, I've now got an exact position. As you saw, I'm going to use a stepper motor. So that now becomes 0. So I say to it, go to position, I'm making numbers up here, 100. Goes to there. Go to position 600. Goes to there. Go to position 2000 and whatever. Goes to there. Go back to 100. Spins back round. That's the idea. That's what we're going to do. This obviously needs decorating. It needs the handrails going on. I'm going to do all that later. I want to get the thing working first. So, first up, let's go and have a little look at the sensor I'm going to stick in and we'll see how that works. Okay, here we are at the desk. Now, as you might expect, this involves an Arduino. At the moment, I'm only using the Arduino as a power supply. It doesn't do anything. Incidentally, I've got one of these sensors here. These are the position sensors I'm going to be using for the ends of sidings and the end of the road over there where the turntable. There'll be one of these on the approach to the turntable, so I can drive a train up and it goes, "Oh, you're in place. Stop." I'll know when to stop. The same in the siding. I'll be able to just drive a train over and go, knows when to stop. I am going to be driving the trains manually in this part of the world. So these sensors are because if you've seen the layout, I mean, certainly the opening bit where I'm standing is about where I sit when I'm driving the layout. I'll stand when I'm driving the layout. And the other end where the turntable is about 6 foot away. So I don't want to have to go over there and stand over the thing. So yeah, little sensors to tell me when I'm getting near it. It won't have full block detection because frankly there's no point. There's not going to be trains running into there under their own steam. Sort of pun intended, I suppose there. Possibly I might run one up to the turntable, which will use one of these to say, now you need to stop at low speed. I'm undecided whether that road is going to get block occupancy on it or not. It probably won't. Right, that's that done. So the next thing I need to do is zoom in a little bit down here. Let's bring this down slightly as well. On the board, we have a whole load of bits and pieces that are worth ignoring. Ignore this little chip. It's not connected. It's not doing anything. Potentiometer's not doing anything. This 10k resistor, all this stuff at this end's not doing anything. The bit we're looking at is this here, this little black thing, which is a Hall effect sensor. This thing detects magnetic fields. I'm going to do another video on how these little beasties work and what sort of wonderful things you can do with them. There's lots you can do with these things. For here, we're just going to look at one working. And over here, there is a red LED and a suitable resistor. And here, let's move this down a little bit, are some magnets. And what this sensor does, I say it detects a magnetic field. So, oh, here comes a magnet. Light comes on. Now, it only detects it one way around. If I turn the magnets the other way around, it doesn't see it. So it only detects it that way around. And there's 5 magnets here. So if I put those there, that's about where it detects it. If I only have one magnet, for example, there's quite strong magnets, quite hard to take apart. I can bring this in, but I've got to get it closer. So I'm going to be fitting a couple of these. The plan is to glue 2 of them either side of a piece of plastic, fit that to the turntable deck, and then if I need more, well, magnets stick to each other, so that's not really a problem. But the right way around again. That's the other thing. I need to make sure I glue them in the right way around. That's the idea. So this is going to be on the rotating bit of the turntable. This sensor will be glued to the outside. It'll come past and go, ooh, found you. And it'll come in, go, oh, found it, back off, and then come in again slowly, step by step, until it sees it. And that will be the 0 point. So there's a few things I need to do here, so I'm going to get on with those. The first thing is, well, actually, the very first thing is I need to glue a wire back on the turntable base because one fell off, so I'm going to do that. Then I need to take one of these little beasties and glue 3 wires to it. There is a 5-volt supply wire. This is why I'm using an Arduino for this, because these run on 5 volts, as does the stepper motor and the stepper motor board. Excuse me. So I'm using 5 volts on this. So there's a 5-volt line, a ground line, and a signal line. And on here I have 5 volts is one end, ground is the middle, and the signal line is the other end. And incidentally with these are quite picky. For example, if I put the magnet above it, it won't see it until it gets really quite close enough to be sort of like on that side. Back it won't see it, the sides it won't see it. These things are quite directional. You can get ones that look up, you can get ones that look sideways, you can get all sorts. These, I'll look up exactly what it is. I think this is an A3144. And it's just a Hall effect sensor. I've got a pack of 10 of them for a couple of quid, so I'm not complaining too much. Right, I've got a little bit of basic soldering to do. and then I should be back in a couple of minutes. Okay, a little bit of work later. The sensor is on the side here. I'll show that a little bit. We'll have a look at that in more detail in a sec. It's held on with blue tack. It's got some wires. I've put the DuPont connectors on the end of the wires just for sanity at this point. They'll be cut a lot shorter than that, and they'll be soldered eventually. So, with a magnet, does it work? Yeah. The red light coming on. Hopefully you can see that. Let's move that in a bit just to make sure. So, yeah. Now, the interesting bit is I need to get the height on this about right as well. So it's... No, I've just moved... I'm moving the sensor about as I'm moving that. So, yeah. So that's the sensor. That is part one of what I need to do today. So, I'll just flip this over. See, I've got a bit of wood on the bottom. I've got the feed wires. Here we have the sensor embedded in blue tack, wires on, a little bit of yeah, still works. A little bit of heat shrink around it. So that's the sensor. That's about where I want it to go. So I'm going to mark that up, and I'm going to fit that probably later, because what I'm going to have to do, note there, S there and there. I shouldn't use the permanent marker for that because it's made a mess. Give the normal pen. So we'll do that there. Send. That's where the sensor's going to go. So I can unplug that and move this out of the way. I will glue that later, like I say. Yeah. Okay, on with the next bit. And we're back. Now the next bit involves the deck. And these two pieces here, as you can see. This is a coupling. It will take a 4mm hole one side and a 5mm hole the other side. 5mm is the shaft diameter for the stepper motor. And 4mm, that goes into, is the diameter of this hole. So that should fit into there, which it does, and it goes down to about there. And what I can then do is I can put that through the turntable deck. I can put that on. I'm just going to get it so it sits about there, and that will screw on. It'll hold this down. Well, the whole weight of the thing will hold this down, so that's not too much of a problem. But that needs to go in with... Let's take it out again if I can get the thing out. Is it going to come out? Yeah, it's going to come out. Now, see, it's a tight fit. It needs a bit of glue. So what I'm going to do is I'm going to rough up the sides of this, and later tonight I'm going to araldite that in. And I'm going to araldite some magnets to a little bit of plastic sheet. So I'm going to find my plastic sheet, because I don't need the really thin stuff I've been using. I need something a little bit thicker. I'm going to get it cut to the appropriate size to fit in the end here. And I'm going to work out exactly how we're going to fit this. I've got some L section, which I think I'm probably going to need, because I can't stick it right on the very end because that rubs against the wall. It's got to go back inwards a little bit. And okay, back. So the tools that we are using. I have 1mm thick styrene sheet, which is that. I have 1.5 by 1.5 mil angle sheet. This is AK, as is the other stuff. I've got some glue. And what I need to do is make a little piece to fit across the end here. Now, there's a lip on the end, which is going to make getting at it a little bit awkward. Tweezers, which will help with that. However, the gap across is the same as the distance there. So if I measure that, which I can do at, let's have a little look, get that right, 27mm. So if I slice a piece of this 27mm across, so move some of this stuff a little bit so I can get this into shot. So I'm going to go here. I'm going to go 25, 26, 27 is there. And down here, 25. Again, I've got the problem. I've got the usual problem if I can't see anything because it's reflecting. 25, 26, 27. That's there. So I'm just going to cut myself a strip of this. Again, sharp craft knife. Now, this is part of the reason I've got the L section, is if this doesn't fit perfectly, I can cope because I'm going to have something else to stick it to. So this is, again, sharp knife. This is quite a bit thicker than the other styrene sheet I was using. Should be able to get that to there, and then that comes off quite nicely. So don't need that anymore. I'll put that behind me. Right, in theory, that should fit in there, and it does. A little bit slack at that side. Tight fit that side, and that's exactly what I want, is a tight fit. So I now need to work out how tall it's got to be. Which is, again, a job of bringing a ruler in. About 8mm. And I can cut that using the guides on here, pretty much. So back that off a little bit. That should do. And this is the beauty of working with a plastic kit. It is extremely easy to modify it like this. So that piece, which is a slightly tight fit, which is good, is going to go. I need to get this. I think so you can see it, and also so I can do it. It's going to go in here. So it's going to have to go. What I'm probably going to have to do is cut 2 little slots in the top so I can fit this in. So I'm going to go, where's the magnets? Around here somewhere. Let's see how thick they are. Oh, they're, I was thinking about it. I know how thick they are. They're 1mm. So if I cut this here, say, that bit there and that bit there. Should be able to go in with a pair of clippers and cut that little section out. And this is just about being able to slide this piece in. So if I just stick the knife on that and go down, there we are. It's taken a chunk of that out. Yeah, whether that's taken enough of a chunk of that out or not, I don't know. Yeah, so this is what I need to be able to do anyway, is modify this bit here. I should be able to shave away quite nicely. There we are. Now the idea is so that can slide in through the gap. I'll do the same on this side. And then we'll stick some L section on it. So what I need to do is really carry on cutting at this a little bit. The cutters will probably help. About there. Like I say, it's just plastic, so I can sort some of these bits out. On this side. Chop a chunk of it out. This is all on the bottom, so you'll never see it. So that's the theory anyway. Just scrape at that until it's a suitable gap. Then goes in that way, and it'll go in there as well. Right. So the next step is the styrene strip. And this, you can get this in all sorts. I mean, as I got this from my local hobby shop, which again is Hobby Workshop out in Chapeltown. Now, I could stick this onto here quite easily. But what I'm actually going to do is stick it in here. So I need some little lengths of it. Yeah. Probably about that. That should do. Two of those. And it's worth noting you can make all sorts of stuff with this thing. And yeah, you can get this stuff in loads of different sizes. I mean, this is L section. You can get I-beams. You can get square. You can get rods. You can get tubes. Lots and lots of stuff. Now, these are going to go on the inside of this here. And then the idea is this will be put in and can be glued against them. So I'm going to do this. Now, this is the Tamiya cement, which is rather good for this sort of thing. It's what I use to put the actual turntable itself together. It does stink, it has to be said. So let's get this the right way round. I should then be able to place that into there. Just press that into place. Now, you see that little white bit in the end. I'm going to do the same on this side here. These are, as I said, I'm making essentially little brackets that I can fit the end plate piece I've made to. Come in with this, check it straight, which it is just about, and fit that in. Try to fit that. That should be into there. A little bit further forward, about there, I think. That should do. A little bit more glue in there. And on that side. Right. And that's just made a bracket carrier for this bit. Now, I can't glue this in yet. I need to stick the magnets to it first, because when that's in there, I'm not going to be able to stick magnets to it. So the goal is going to be to put a magnet on that side and a magnet on that side. I'm just going to take the edges off where I've snapped this, smooth the edges down a little bit. Take like a little burr off the edge. Just because this will make sliding it in a bit easier. Tip for mold line removal on kits: use the blade but drag it down. So if you've got a plastic kit that's got fairly obvious molding marks on it, that's a good way of getting rid of it. So what I now need to do, glue out the way, is mix up a little bit of araldite. This needs a magnet putting on either side. Now at this point it doesn't matter which way round the magnets are, because that can go into here either way round. So I'm going to get the magnets, which are over here. I'm going to get 2 of them to start with. And the other good thing about this is these magnets will quite happily hold themselves in place. I also need the steel rod, which is going to go down the middle of that. And now I need the magic stuff, which is going to hold it all together, which is, of course, araldite, which is wonderful stuff. You do have to work quite quickly with it. So a lot of this, it's been used on the back of this. Basically, you just need a piece of card to mix it on. And if you've never used this stuff before, this is great fun. It is a 2-part epoxy resin adhesive. So you put a bit of one part. And one thing that is very, very important when you're using this stuff, squeeze a bit of one out first, put the lid back on, and squeeze another bit out and put the lid back on that. You don't want to have both tubes open at once and end up putting the wrong lid on. This stuff is remarkably strong, and once it is stuck, you ain't taking it apart again. So if you put the wrong lid on, have a guess what's going to happen next time you come to try and use it. And if you guessed you won't be able to get the lid off, you are correct. So that needs a little bit of this to go onto here. Yeah, let's put some of this onto this bit of plastic card. I want a reasonable sized blob of it. What I'm going to do is sit the magnet on that, and I now need something made of plastic to press it down with. So this bit of heat shrink tubing will do quite nicely. And it's more or less in the middle. It doesn't, because I'm making a position sensor, it doesn't actually matter, because what's going to happen is I'm going to be saying this is the position it's going to go into. The next bit is a little bit on this. And here I don't need much on this shaft, because that is going to go into a hole. If I bring this back in here, this is going to go into the hole, is going to get pressed down, and that is going to smear araldite nicely along the inside of the hole, and I've got a little bit around the edge there, which will help. Don't want too much, just a little bit, and that'll hold that. And then the next bit is turn that over. It will grip it pretty quickly. Scrape up a load more. Lob that on the back. Yeah. Try not to have glue that will glue it to the desk is probably a good trick. Will that go on that way? It'll go on the other way around. That's fine. As long as it goes on, I'm not bothered. So that then can be pressed into place, and can have its glue smeared around a little bit. Magnets are wonderful things. These little neodymium rare earth magnets are incredibly strong. I use them quite a bit with tabletop gaming things for sticking arms on robots. Sometimes you get the situation you want to be able to stick something, but you want to be able to take it apart again. And using a magnet is perfect. Now those two magnets are going to attract each other. So there's one on each side. So I'm just going to leave that to dry. I'm going to leave that to dry. At some point, the sensor is going to get araldited to the side of the mounting point. That is not happening today. I need to set this up. I need to make sure it all works. I need to make sure I've got this the right way round. I need to make sure I've got all the positioning correct. And then I need to make sure I can get the height of the sensor correct on the side of the well. So that is all coming for me tomorrow, for yourselves shortly, because this was prep work on the turntable. I'll be back for yourselves shortly when I'm going to stick all of this together, when this has had a chance to dry, all this araldite has had a chance to cure, and then we're going to put it together, and we're going to make sure the sensor still works as the table rotates. So I will catch you in a bit. A quick update. You may be able to hear this screeching sound. I think my Ender 3 V2 has reached its last days. Nozzle is too low temperature. Yeah, turn that off. Lift that up. Yeah, the nozzle isn't too low a temperature. I know exactly what the problem is. In this bit, there is a temperature sensor, which is what these wires go to. It's a thermistor, so it's a resistor, the resistance of which varies with temperature. The bed's still nice and warm, so it's only just recently gone. Yeah, let's peel this off. Yeah. It's got through about 5 of those now, so it's not just the sensors, it's the printer itself is doing something to them. I've had this quite a few years now, about 4 years, 4.5 years, something like that. I think it's time to get another one. I've got the 3D resin ones down there, but they're not really suitable for what I use this for, so I get another one. The frustration This is allegedly the bracket mechanism for the turntable that's going to hold the motor. Yeah, that one wasn't printing properly. I changed the filament reel. This is now the second one that's got about that far, and then it's decided, nope, not playing. So, anything I need to do in the short term that needs 3D printing is now on hold. Yeah, that's going to be a problem because I need to print some bracketry for the point servos. I was doing a video, well, yeah, so you've seen the early part, where I was looking at doing the turntable and the various bits and pieces for that. That's coming along quite nicely, but I need the motor bracket. So I'm going to have a little bit of a think on that. I suspect my friend here is going to get replaced. To get something a little bit more modern, a little bit quicker. Anyway, yeah. I'll think of a way of finishing the video off. There are some other bits and pieces I can do in the meantime, so I'll have a look at those. Right, okay, back. The 3D printer debacle continues. Anyway, new one's arrived. It's upstairs. I'm not going any more into that in this video. So, what we've got, and the last one, I have got this piece of plastic with a magnet stuck to either side of it. I've powered this back up. Before I can fit this to the turntable deck, there's one very important check. Which way round does it go? So, right. So, that side has to face that. So what I'm going to do is put a few little blue squiggles on that side. Just so I've got that. I'm now going to get the turntable bridge deck from where it sits, which is here. This has its little bit araldited into it quite nicely, and it has the little fittings on the end. So what I need to do, put that end of that somewhere where it's out of the way, is fit that in there, like so, with a little bit of glue. So I'm going to do that. This is where these little plastic strips at the side really come into their own. Essentially, what they're doing is meaning the fact that this bit is not 100% the correct size doesn't matter. It can be slightly too wide, slightly too narrow. Well, it can't really be slightly too wide or it won't fit. It can be slightly too narrow, and those bits of plastic will see me good. So that can stay there. I can then bring this over here, and you can see the little red LED over here lighting up. That works. Now that is going to take a few seconds to stick. So while that sticks, I'm going to find the well, which is over here. So here we have the turntable well deck. It's not really worked very brilliantly on the desk over here. This thing is basically a little bit too big. Right. Anyway, let me just put this down here. I'm going to have to lift it up because obviously that drops through a little bit further. What I'm wanting to do is just make sure that this can detect it through the side. And it can. And in fact, it detects it quite nicely. So, excellent. Right. Take that back out. Let it sit that way up again until that's properly dried. Polystyrene cement. It doesn't take very long to dry, actually. A couple of minutes, that'll be dry. Right. Now, because I can't put the motor on the bottom of this, I've got the coupling. There's a coupling that fits on this shaft. Allen key grips onto that. Obviously, it's got to go through the deck first. Whee, swingy bits. The motor then fits in. Another Allen key tightens. That's fine. I just need to make the bracket to hold the motor to the bottom of the well deck before I can put it all in. The next steps, I need to get this in and get it tested. So I want to be able to get this in, get a motor connected, probably to this Arduino here. And to start with, all I'm going to do is just have it slowly rotate through 90 degrees or 180 either way, past where the sensor is, so I can see that that works. That's fine. Once I know that's working, I can take it apart and I can paint it. I can put the railings on this, which obviously aren't on here at the moment. To paint it, I'm going to have to take the rails out. This will then get primed all over. Beauty is, I've now got a handle to hold it by, then I can sort of grip it in things. The base deck needs priming. That needs painting in a concretey colour, which I'm sure I can find something suitable that I can spray it with. I'll airbrush all of that. And then job done. I can put it back together. Now, yes, this is going to have all sorts of weird, fancy software eventually. The goal for now is I want to connect it. I'm going to put the little sensor LED somewhere I can see it, so I can see what it's doing. And I'm just going to have two buttons, one that says clockwise, one that says counterclockwise. And I'm just going to drive it manually like that. The reason I want this working is because when I go back to the layout, in fact, if we just go back up, I will show you. Break out of this. Here's the clear bit of space and a 3D printer that probably needs stripping for bits. I might take the vertical stepper motor and screw, I might take that off because I might be able to use that for something. Yeah, up here's got a bit cluttered again, so I need to sort that out. A lot of this is where I've moved stuff to make space to bring the other printer down here. But yeah, what I want to do is get this out of the way. I want to get the turntable in. I'm going to get the sensor glued firmly onto the outside of it where I've got the blue tack at the minute. I don't need that in here anymore. But I want to get this thing in. I want to make sure it works. I don't want to put the sensor on until the motor's in place because I'm going to be moving things around quite a bit on the top of it. Basically, it's a bracket. It's going to sit over that hole. It's like a square with a big hole cut in the middle and space for 4 screws. The wires come out the sides. The motor fits on top of the bracket. There's like the coupling sits there. And that'll hold it. That's brilliant. Yeah, that'll hold it. That'll also hold the deck in nicely. I probably am going to print a little collar to fit around it. Just to act as a bit of a spacer, really. Don't really need it, but I'll probably do it. Then, at some point, these wires are going to be cut short. There's going to be a little terminal block. They'll terminate into that. Just screw terminals. I can bring some other screw terminals in. It may even be plugs. There'll probably be another board somewhere which has power input. And then all of its mechanism and its controls are going to be stuck to the bottom of this. So we come over here, look down through the hole. As you can see, there's going to be a keep out on this. So look over here, it'll probably be something like that. I don't know which side it's going to be on, but I'll mark it out and I'll say, right, nothing can be fitted in that area. Or if it can't hang down very far. I mean, there is like a wooden beam here, so I can hang down a little bit. I've got the spacers. But what I'm wittering about, I want to get this in before the rest of the track comes in that goes down this side. Basically, because if the table's in and I know it works, I can then lay the bit of track that's going to come along here somewhere and go into the middle of it. And the little track that'll go over there with the storage bit. Yes, I've got some sensors to build. The parts for that are due to arrive fairly soon as well. So that's about it for this video. There's plenty coming up. Probably the next bit is going to be powering that little board extension up there. I've got everything I need to do that. The ESP32's turned up. The PCF8575 sort of I/O boards, they're all here. I've got the DTC2s I need to do. So what I can do is I can power that up. I can terminate the wires on board A over in the corner. I can get that terminated and powered up. And then all I've got to do is make sure all of these wires that hang outside here, and there's quite a few of them, and there's some hanging under here as well, are off the side somewhere so they're not touching any rails. Yeah, I can't run trains under there because I've got stuff hanging down, but what it means is I will be able to power up and run trains around to that board join and just check it all works. And then I'm going to start on this board section here, which, again, I can just about do all of. I want to get the rest of the track laid. See, that board there is finished. There's no more track going on there. This board has got more track, more droppers, more power feeds, some sensors to go on it. That one there's obviously got quite a lot more to go on it. But I'm just going to work my way around. I'm going to get that one powered up. So that'll be a video coming up soon. Printer, yeah, I'm going to get that going. It's FlashForge AD5X I've gone with. So I'll be able to put this tasteful purple filament on it, print that motor bracket. There's some other bits and pieces I've got going. All those coaches down there, all the clerestories, they're all going to get interiors fitted to them. And you may notice, if I zoom in a little bit, if it focuses, there's a load of wagons down there with a load of magnets because I've been playing with those as well. Let's see how that goes. But anyway, that is it for this video. It was going to be a bit longer. I was hoping to get the motor installed and get at least to the point I can make the thing sit there and spin round today. Yeah. Anyway, I'm not going. I'm calm. To be honest, actually, I am quite calm. I've had that thing 4 years. I've had my use out of it. I originally bought it to do some terrain for a tabletop game because buying a printer and printing my own was cheaper than buying one table's worth of terrain. I got that table's worth of terrain out of it. In fact, I've had several. So yeah, she's done sterling service. But I will see you all in the next one. Enjoy the rest of your weekend. Comments more than welcome. There will be a video on the 3D printer. I'm going to do that as a separate thing because that way anyone who's frankly interested in trains and not interested in 3D printers can skip it. And anyone else who's interested in 3D printers but doesn't give a damn about trains can not get confused about that. Let's compartmentalize these things, people. Anyway, yes, enjoy the rest of your weekend. I'll catch you all in the next one. Likes, comments, shares, subscriptions, etc. are more than welcome. Other than that, thank you very much and goodbye.